Today I want to do a quick video showing how to use a sprite sheet in Canvas. So Canvas is if you're not sure what it is, it's actually just a built-in thing in JavaScript and most modern browsers where you can draw images, bitmaps, vectors, just anything to a little 2D drawing pad. And there are a lot of built-in methods to do this. You can draw images directly from PNG files, you can draw in rectangles, you can make curves, and there's a 3D version too that works with WebGL. So Canvas is getting to be pretty powerful. And there's also something called request animation frame. Request animation frame. And that lets you kind of do pretty even rendering in a browser rather than just doing something in a big loop like you normally would in a game. So in this demo, I want to go over using a sprite sheet, and I've got a little Bulbasaur sprite sheet here, and I've got some trees I'm going to put in the background, and I want to add some keyboard events so that we can use the arrow keys to move the Bulbasaur around and cycle through all of the states in the sprite sheet to make it look like he's walking around, and we're going to do all of that on a canvas. So I have this nice boilerplate that I found. These guys published it looks like, and it has everything done we need to do. It has a request animation frame sort of polyfill. Well, it doesn't have a polyfill, but it has a compatibility layer for each browser, and it also has some detection, so it figures out how big the screen is, and it'll automatically size your canvas for that. So that's pretty cool. And it also has our rescale, it has our setup, it has our init, it has our draw. So actually all we're going to do, we're going to throw our code in here, and we're going to throw our update code in here. So I've got this code here in my Atom editor, and again, they've got all this nice boilerplate for us, so all we're really going to have to do is throw our code inside of draw and update. So alright, getting started, I've got the Bulbasaur sprite sheet here, and I've got some trees I'm going to put in the background. Sorry. And what we're going to do first is actually add these images into the page. So I'm going to say div style equals display none, and I'm doing this because I want to have these loaded onto the page, but I don't want them to be visible. So we're going to load these two images inside this invisible div here. So I'm going to say the ID is equal to tree image, and we'll say src equals tree.png, and I'm gonna set the width and height to make it a little bit smaller, just so I don't have to deal with that later. Let's do one more image, and we'll say this is the bulb image, and src bulb.png. And I'm not going to set the height and width on this because I want that to be what it actually started as. We've got some variables that the boilerplate has declared here, so I'm going to keep declaring more variables here, and what I want to do is add in these additional images. So I'm going to do get element by ID. I'm going to have a tree image, and it'll be document.get element by ID tree image, and we'll do the same thing with Bulbasaur image. It'll be document.get element by ID bulb image. The first thing I'm going to do actually is render these trees in the background, just so we have something in the background of our canvas to make sure we know it's working. I'm going to create a new function, and I'll say draw trees, and what we're going to say, we're going to make some variables here, and I'm going to say size is equal to 20. That's how big I want the trees to be, and then I'm also going to declare I equals 0 and I equals 0, because I'm going to make two loops, and this is vanilla JavaScript. Obviously vanilla JavaScript is function scoped, and we're not using the new like ES6 let and const, so we're going to declare all the variables up here in the function. I'm gonna iterate over the global height, and I'm gonna say I plus equals size. So that'll be the tree size, but we also want space between them. So I'm just gonna say, yeah, let's get a space. Let's make it 40. Let's make it twice as big. So this is going to give us a background of evenly distributed trees. The size of the tree will be 20 pixels and the space in between them will be 40 pixels. So this is going over the height on the y-axis. We're going to do the x-axis now. So we're going to go on the x-axis. So global width. Actually, you know what? Just to make this easier to think about, we're going to go down the width. And then we'll go down the height. So we're going over the x-axis and then down the y-axis. And what the boilerplate looks like right now, I've actually got this little HTTP server running here. It's just a Node app, and it'll serve on port 8081. What their boilerplate did, it just drew some line. It drew an example line here. This is what it actually looks like right now. But what we're going to do, we're going to go through the width and then down the height and draw trees. So global height and I plus equals size plus space. And the CTX, that's the canvas context, that's what we're going to actually draw to. So there are a lot of I put some links here. This is the code I'm going to post up. I put some links, but the canvas, you're going to issue commands to it, and when you issue commands, it's going to draw things. So we're going to do something called a draw image, and this will draw images onto the canvas. And we have these tree images, so I can just say tree image, and I can say that's going to be my X position. So I is X, I is Y. This is just like a regular coordinate plane. And we're going to say tree size, or sorry, we're going to say just size, I guess. And yeah, so let's think about this real quick. What I want to do is this one where I'm drawing the X and the Y and then the height and the width of the image. So we want to draw the size of the image. So I'm just going to say size twice here. Let's look at their code. They've got a draw example. I'm going to just get rid of this example here. And instead, I'm going to say draw trees. And if we did everything right, this should go ahead and draw our stuff here. Okay, looks good. So no errors. We have our trees evenly spaced. They're pretty small with pretty big space between them. Everything looks correct. So we've got trees going on now. The next thing we want to do is actually start drawing this Bulbasaur image, and that's going to be a little bit more complicated because what we have to do is figure out how we want to move it. So starting off right into that, I'm going to start with a function that I'm going to call let's call it function hero state. And it's typical in games to call the main thing that you're moving around directly with the controls the hero. That's just kind of like a convention that people usually use. So let's say var state, and we'll have it just a state variable in here. And I'm gonna start this thing off at global width divided by 2, and y is going to be global height divided by 2. So the thing, what I actually looked at this before I started this video. This image is 256 by 256. You can see it down here in the corner. It's 256 by 256. That means each of these components, I can assume that they are 64 by 64, since that's 256 divided by 4. So we're going to start off with that assumption, and let's see if that works. So I'm going to say the height is 64 and the width is 64, and that will be it. I think we're going to just start off with that. I am going to return the state object. So the way this is going to work, I'm going to say I'm going to give myself a hero, and I'm going to set it equal to new hero state. Okay, so let's give this a try. What we need to do next is write the current position. So I'm going to make a thing called write hero to canvas, or actually let's make it a little easier. Draw hero. Okay, so we're drawing the hero. I'm going to say var state is equal to hero dot state, just so we have access to that a little bit easier. And then I'm going to say context dot draw image, just like I did with the tree. This is going to be a little bit more complicated though, because we're drawing from a sprite sheet, and we want to draw the correct iteration in the sprite sheet based on which key we press or something. So to start out, we're not going to do that. We're just going to draw a very simple image. We're just going to draw the let's say bulb image. We're going to use these same kind of arguments, and then I'm going to say state.x, state.y, and state.width, and state.height. Let's see if this works. I'm not sure if this will work, but let's just make sure that we're on the right track here. Okay, so that drew our whole sprite sheet. That's not what we wanted though, right? We did not want to draw the entire sprite sheet. We want to draw the first position of the sprite sheet. So I think what we want to do, we want to, if you check out the canvas, they've got a more complicated method signature here, and it lets you specify a part of the source image. See, so they have this picture of this hippo here, and they're not rendering the entire thing, they're rendering a part of it. So this S, X, and XY is how far you move down from the top corner before you do the S height and S width, which will be the crop area in here, and then this is the actual X and Y coordinates that you're going to write onto the entire canvas. So let's give that a try. Let's do that method signature. The one thing I want to do though, I want to update my state because I want to have like a position, and we're gonna do 0, 0. That'll just be the first down state, but the problem is I really have to have an XY coordinate for these two of where I'm starting at, even though I know the height and the width is always going to be 64. Since I've got that 256 pixel image, I'm gonna have to keep track of where I'm at, and in my state here I'm going to keep that in XY coordinates. So that'll be X and that'll be Y, and that'll correspond to this one in the corner here. So if we moved it over and we made it 64, 0, it would be this one. And if we made it 64, 64, it would be this one here, because it would be down 64 and over 64. So let's do that too. So again, it's just two more in the method signature, it looks like. So I'm going to, instead, I'm going to do state dot position 0, that's an array, so I'm accessing the first index in that array. And then I'll do state dot position 1. Whoa, that doesn't look good. So it said valid arities are 3, 5, 9, but 7 arguments were provided. So I got something wrong there. I need 2 more arguments, it looks like. So I got the height and the width, and I need the d width and the d height. So that's the d width and the d height must be the actual size of the image I'm painting, not just the crop area. But that's going to be the same for us, so that should be fine. So this is the position. That's sx xy. This is s height, s width right there. Yeah, so what I need to do, I need to get that height and width of the crop area. So same thing right here. Alright, so 9 arguments to that method, kind of annoying, but here we go. There we go. Okay, so we've got that main Bulbasaur image. That looks a little blurry, but it's basically what we wanted it to look like. So we can fix the blurriness later. But just let's actually copy paste this here so we can have a reference of what these arguments are. So xy pair, xy pair, xy pair, xy pair, 4 xy pairs. Okay, so the next thing we need to do is start moving this thing around, right? Like we want to have some keyboard events so that we know what happens, or we can figure out what happens when we press down on it. So the next thing I'm going to do is start with a keyboard event listener, and I'm gonna throw that code. I'm just gonna try and separate this from the boilerplate. I'll throw that code in here. What we want to do is document.add event listener, and I'm going to do it on key down, and we'll have a callback here with an event object in it. And I think what we'll have is a code, and it'll be event.key code. And I happen to know these. There are a few codes. There are so there's 37, which is arrow key left. There's 38, which is arrow key up. And there's 39, which is arrow key right. And finally 40, which is arrow key down. And that's the ASCII table. So let's check out the ASCII table. Oh, that's not the right one. Oh, you know what? Sorry, guys. It's the JavaScript key code list. That's what we need to look at. Okay, let's check this out. Right. So the way this works is you get numbers from this event on key code, and they correspond to the various keys on your keyboard. These are the ones we want, right? Because we want to move around this thing. So I'll say if codes.index of code does not equal -1, we'll say event.prevent default, and I'm just gonna log this, because if we did event.prevent default, any keyboard button you press on this page, it'll ignore it. But we do want to ignore these arrow keys because we want to capture them and do something with them. So let's see code. Let's see if this works. Let's go ahead and try this. I'm going to refresh. Okay, it looks like it's working. You guys see in the console here, we're doing some stuff. Looks good. Looks good. All right. Not sure what that is. Interesting. That's not, this is some plugin, it looks like. It's not my code, apparently. Interesting. All right, so if you have, the lesson is if you have weird extensions installed on your browser, I guess sometimes they have JavaScript errors. All right, so this does nothing for us right now. I just want to add this event listener because what we're going to do is we're going to let the hero move around, and using that we're going to we're basically going to move it based on what key was pressed. So I'm going to make some variables in here. I'm going to make a variable called iteration, and I'm going to set it to 0. And we're going to loop through the iteration. So we'll say this is 0, 1, 2, 3, and it'll be the same for each of these. You'll go through iterations. I'm going to make a function called next down, and we'll keep doing this. We'll make another function called next left, another one called next right, finally another one called next up. And these are going to give us the next coordinate position. We'll set the state position in here. It'll just kind of change what the current state is based on where you are. So the thing is, we're gonna have to make an iterator. I'm gonna make just something called iter, and what it's gonna do is increment the iteration. And then the problem is if we go past the end of the iteration, so if we're going 0, 1, 2, 3, that would be bad. So we want to say if iteration is greater than the max iteration, which will be 3, we'll just say iteration equals 0. So if you roll over, you're going to roll over at 3. That's the idea here. So the first thing we're going to do, and this is just called iter, and the next thing I'm going to do is say state.position, because I want to reset the position. And what I want to do is set an XY pair. So we're going to set an XY cropping coordinate on the sprite sheet. And this is how you have to do it with the sprite sheet. We're going to iterate through positions in the sprite sheet. So we're going to set the coordinate pairs on these that are the cropping areas. So if we cropped here, it would be 64 over and 128 down, right? Because these are 256 pixel images if you wanted that. So for next down, we're actually going to change the y or the x iteration. Or sorry, we're not going to change the x iteration, or we are going to change the x iteration because we're going to loop through these, but we're not going to change the y axis at all, because the y is always going to be the same for down. So I know down is going to be 0 for the y. I just know that. X is the tricky part. It's going to be iteration times 64. And if that makes sense, or if it doesn't make sense, the idea is there's 256, so if you divide by 4, that's 64, and I've got 1, 2, 3, 4, so 64, 128, and then so on and so forth until the end, right? So it's gonna just keep moving over a little bit, and then we're gonna do the same thing for all of these, and I'll say state dot position, and same thing with left. It'll be left. Where's left? Okay, so left is the next one down. So the x-axis will be down 64. So, or sorry, the y-axis. We're going to move down vertically 64. But then the iteration is going to be the same. it's going to be times 64. So these should be fairly similar, all of them. We're just kind of making our self-convenience methods. So that looks good. Right start. So the right start should be right here. It'll be down 128. And there we go. And this is getting a little old, so we'll just do 64 times 3. These are all essentially the same, right? We're just pushing it down farther. Okay. And the last thing I'm going to do, I'm going to make a function called move rather than setting the state, and it'll just take an x and a y. And we'll just say position.x equals x. Okay, so I just didn't want to have to keep messing with the state directly. I just want to have a move function. I'm going to expose all of these. So we're going to say next up, next up, next right, next. So if we were doing ES6, we wouldn't have to do this, but we're not. I want to do this in vanilla JavaScript because it'll work on most browsers, and we don't have to use Babel or anything. Okay, I missed one. Next down is next down. So all of these are exposed now. When I create this hero state, I've got this hero state. It's got its internal state, it's got its internal iteration, and when we move these, it's going to move its state a little bit, but we can access these from outside of the state, and these are all exposed on this object that we create from the new method. Okay, so the trick is now we want to listen for this stuff and do stuff. What we actually want to do, I was thinking about this, we'll create a map. I'll say, here we go, we'll do var map, and we'll make the first one 37. And these will have functions on them. And what these will do, it's when keycode 37 gets pressed, we'll say hero state dot, oh, sorry, I think we called it hero, right? Is that right? Yeah, we just called it hero. So we're gonna modify hero. So 37 we know is left. So what we're going to say is hero dot next left. And the other thing we're going to do is increment its position. So if it moved left, we want to move it left. So we'll say hero dot move, and we'll say this previous position plus some position. So I'm gonna grab the old position. I'll say hero dot state, and it's going to be xy. So I'll say state dot x minus 5. Let's move it 5 pixels, and then I'll say state dot y. And these are pretty much going to be the same. So I can just grab this and I'll copy and paste. And 8. So I'll put some comments here. This is left. This is up. This will be right. 39. 40 will be down. Let's make sure we did that right. 37 left, 38 up, right, and down. So left, up, right, and down, and left, up, right, and down. Right. Okay. So up, it's going to be different. We're going to move the Y. So I'm just taking the current state and changing it a little bit. So we'll say up is going to be minus 5 because Again, we're on a computer, so the coordinates start from here, not like when you're doing some kind of math homework in school where coordinates start down here. The 0, 0 is not down here on a computer, it's the 0, 0 is up here on a computer. So if we want to go up, we want to go negative. All right, so right, we're going to go positive 5, and let's change this so it's next up. Next right. And okay, for down, we're actually going to add, because again, the coordinate plane is starting from the top down, next down. Okay. So this is going to be kind of cool. What we're going to do, we're going to say map for the code and then call that function. So maps a code to a key, and then when you get that key, you call the function that it returns. It's maybe it's a little fancy, but it'll get the job done, and it'll be kind of easy to read this way. Or easy, maybe not easy to read, but the code will be more organized. So we've got our key down. It should be moving our hero. And I think what we should do is log this state every time we get a key movement. So let's go back to our boilerplate here. And I don't know why this log is preserved. Let's get rid of that. So I'm going to do up. I'm pressing left right now, so what my position should be doing is moving, and I see that it is not moving. That doesn't seem good. Position is undefined. Okay, so we have a bug. Position. Right, so the problem is I didn't put state here. Okay, so state is this variable up here, and I had position down inside of state. And I actually don't want to do position either, I just realized. So let's get rid of that. It should just be state X and Y. So, okay, that looks better now. Let's refresh this. Console. I'm pressing up. Y is decrementing by 5. So that looks good. That's actually correct. And our position should be, yeah, it's iterating through there. Maybe not the correct numbers, but we'll give it a try. Okay. So we're going to be iterating our position. We're going to be moving it on the coordinate plane. And how do we wire this up now? Because it's obviously not doing anything. The Bulbasaur is just sitting there in the middle, not doing anything. And the thing is, what we did, we just rendered this in the draw function, but we actually have to render this stuff in the update. So what we're going to want to do now is draw this in the update. So I'm going to say draw hero every update, and let's see what this does. Let's go ahead and try this. Okay, so it looks like it's working. We're actually iterating through. It looks kind of cool. He looks like he's moving, but the problem is this is a thing about Canvas. What Canvas actually does is it draws on a coordinate plane, but it doesn't clear it. So what you really have to do is keep everything in memory, and you need to draw this every time essentially, or at least you need to clear the areas that need to be cleared and then draw back over top of them again. So let's do that. There is something in Canvas called clear rect. So I'm going to say CTX, that's the Canvas context, clear rect. And I'm just going to draw a clear rectangle, so I clear out everything from last time, and I'll do, that's from the top coordinate 0, 0, and I'll do global width because it's X, and then global Y, or global height because it's Y, and this should clear that stuff out. So let's try this again. Now, unfortunately, I don't have the trees in there anymore, right? So I've got my little Bulbasaur moving around, but I don't have trees. So we do have to draw the trees again every time after we clear the rec. So now you have to really think about what order do these things get drawn in. So first I clear it, then I draw the trees, and then I draw the hero. So let's try that. And there we go. And the performance should be good because we're using request animation frame, and it'll only let you go as fast as your browser can repaint it. So it used to be that people, when they made a game loop, they'd have to use set interval, and set interval would give you a loop that would occur at a time interval, but you may not get good performance out of it. But anyway, this is actually all I wanted to show you guys. This is the whole thing. This is using a Spritesheet. I built a Spritesheet. I listened for keyboard events, and when I got those keyboard events, I moved and I iterated through the Spritesheet. And what I did is this is kind of like an object-oriented programming thing. I encapsulated all of this behind an object, and I exposed these methods to let us move it, so that we didn't have to do a whole bunch of math. All I had to do when I knew I needed to move, I got to call next up or next right or next down or whatever, and it would move through that next iteration in my Spritesheet. Let's see if we can make him a little bigger here. So it seems like it's working kind of like the way we want it to. And if we wanted to make him move faster, you could just change these. Instead of just moving 5 pixels every time, you could move, do like a variable here, and we'll say move by equals 10 and far. Yeah, now he's moving a little bit faster. Pretty cool, right? Okay, so that's all I have. Thanks for watching.